I'm going to talk through some of the homework, and you know that for homework you should be doing page 86, problems 1 through, let's see, we have 1 through 8 all, and 1 through 8 are pretty easy because you're just using the addition property. And if you look at what you have in number 1, these two little segments are congruent, and these two little segments are congruent. So the addition property says if you add two little segments, the big pieces are also going to be congruent. So because this is marked up the way it is, I can conclude that AD is congruent to AC. So that's what I'm going to have for 1A. So for 1A, I have AD is equal to AC. And if you look at B, look at what's marked up. So you have an angle. So these two angles are congruent, and also these two angles are congruent. So if we add a pair of congruent angles, right, we're going to get a big angle that's congruent. So what I can say is that this whole angle here, which I have to call JFG, so I can say for part B, the measure of angle FJB, the measure of angle JFG is equal to this big angle, which I'm going to call JHG, measure of angle JHG. And if you look at number 2, well, they're talking about the subtraction property. And what I'm going to notice is that we know that RT is congruent to SV, but they both share segment ST. So if I take ST off of each one of them, I'm going to be left with two little segments that are congruent. So for number 2A, I know RS is going to be equal to TV. And the same thing is true, but with angles for 2B. I have two big angles that are marked as congruent. And within those two big angles are two little angles. So if I take off the little angles, then my remaining angles will be congruent. So for 2A, I know that I'm going to have RS is equal to TV. And for 2B, I'm going to have the little angle YXZ. Angle YXZ is going to be congruent to the little angle in the other one, CBD, angle CBD. For number 3, I'll just talk through them a little bit. Number 3, classic example of the addition postulate. We have two congruent segments here, two congruent segments here. So what we know is that this whole segment is congruent to this whole segment. So segment PN is congruent to segment SN. Segment PN is congruent to segment SN. So segment PN is congruent to segment SN. Or if you just want to write this, PN equals SN, that's also correct because you're talking about the length of segment PN and the length of segment SN being equal. For number 4, what I know is that, so this is a little bitty proof, and what we know is that TEV is equal to XEW, and I'm going to start this off with statements and reasons. So really, for lack of anything better, when I have to do a proof, I just write down my statements and my reasons. And it's good to copy over the diagram, but I'm being kind of lazy here, so I'm not going to do it. Not that you should do that, but we know that our first step has got to be our given. So our first step is angle TEV is congruent to angle XEW. And that's given. And I know the last step needs to be TEW congruent to XEV. And just by looking at the diagram, I know that I could create those angles. So angle TEW is just lacking this angle in the middle. TEW is exactly the same as this little angle plus the middle one. And XEV also is my little angle that I have plus the big one. So this is a two-step proof. All I have to do is use the addition postulate. I'm imagining that I'm adding angle WEV to both of these little guys, and it's going to give me these big angles. So step 2 is my last step, and that's angle TEW is congruent to angle XEV. And that is just what we approved in school today, the addition property. And I'm going to stop this and start a new video.